Okay, so current task is palindromic substring 647. I saw that in the past, I see, like 1 year ago, something like that. Oh, that's interesting. It's like 2 days from being like, yeah, no, it's exactly the date. Today is exactly the date. 1 year ago, I solved this problem. So let me edit that one. So this one is, I guess it's a pretty easy one in terms of like finding palindromic substrings in the current string. Let's make it a little bit difficult. Like, let's assume I have this O F F O and say mama and M. Oh, like make it a little bit easier. 4 and then like this. So M A F O. Okay. O F O and then M A. And they, let's say, have I 0, 1, 2, 3, 4, 5, 6. And let's say what the required number of palindromic strings in it. Okay, so what it number of palindromic substrings in it. Okay, so A, B, C, so this is gonna be always palindromic. Okay, so let's assume I will. So if let's say I have like a palindrome length of 3, yeah, it means that I also have a palindrome of length of 1, at least. Something like that. Um, so this is string. So my idea was um, to check if to have a DP array, and let's say have a length of palindrome that ends with I. So let's say palindrome with length of m. So 1 here, length of I, and here like length of 1, and then here length of 1, and then here is length of 1, and then here I actually will have a length of like, say I check the length of the previous one, 1, and I check if these two letters are coinciding. If they are, then it means that it's a palindrome of length of 3, and then here I'll have a palindrome of length of 1, and then here length of 1. But the problem is when I have like palindrome length of 3, let's say I have like something like, so let's say I have like palindrome of length of 6. Doesn't mean that I have a palindrome of length of 4, length of 2, and then here I'll have length of 1, palindromes like, if I have like palindrome of length of 6, it will mean that all palindromes inside can be 6 plus, let's say, length 6, 1, plus so things length here plus palindrome inside with length of 4 plus palindrome inside of length of 2 and plus all the small teeny tiny little bit palindromes here. But the problem is that let's say I have like AA double A here. Will I count them? If I have like frequency array, some kind of that. Let's say, yeah, I guess I can count them. So like if I have so A, let's say, so like here A also gonna be separately uh, A, and then A, and then A. So I already used too many A's here. This one is single cell. Let's have this one as a single cell. Yeah, but they all doesn't end with like this one. So the only one that ends with the ending suffix or like ending indexes like this palindrome, then this palindrome, then this palindrome, then this palindrome, then this palindrome, and then this palindrome. There are like a gazillion of them. You have like something like this. So how we should count the AA? Okay, AAA, AA, and AA. Okay. Should I save here like all the lengths of the valid palindromes? I feel that yes. And doing like this DP iterations. Yeah, like right now I'm thinking about 2D DP, two-dimensional DP. So let's say I have like this um, string, and I have like indexes for the start, and then here for the end. And then I have 0, 1, 2, 3, 4, 5, 6. And then here also 1, 2, 1, 0, 1, 2, 3, 4, 5, and then let's say 6 here. And then I'll fill up this matrix with So like with true if it's palindrome and false if it's not palindrome. So I'll start at the diagonal. So diagonal elements, they're all palindromes. And then I'll start moving. The count of all the substrings, the count of all truths here will be the answer to the number of palindromic substrings. So I already have here what? I already have here like 7 palindromes, already 7. And I'll need to check if I can expand it. So like in order to check if I can make a string from 0 to 1 palindrome, I need to check basically I need to check what the middle part. The middle part is empty because like and I need to check the beginning and start and end letters. Start is like in the string from 0 to 1 indexes is like MA string. So let me just write it down. So here we have start M A O F O M A, and here I also have M A O F O M A, and like a string that starts at M and A that ends at A, so it's MA, and I need to check if it's palindrome. How to check it? I need to check the middle part. The middle part is empty currently, so there are no characters in between M and A. So I need to check just start and end characters and they match. They don't match actually, so I put false here. And then I do the same kind of procedure A from start from A and to O false here. Start from O end with F false. Start from O F ends with O false. Start with O ends with M false. And here also false. So the result hasn't changed much, so it's still 7 palindromic strings so far. So I proceed with the next one. So I start at 0 and with 2. So like this have this MAO. MAO. So to not check if MAO is palindromic, I need to go first check if the middle part is palindromic. Middle part is like and starts at start plus 1 and ends with n minus 1. So like starts at 1, ends with 1. So it's like this, true. So it's already true. So what I need to check is like start and end characters here. M is not equals O, then it means like here is also false. So moving forward, I need to check AOF if it's palindromic. No. OFO. So now, again, I need to check middle part. Middle part is for the starts at so it starts at 2 and ends at 4. So I'm looking for the starts at 2 ends at 4. I'm trying to fill up this cell with true or false value. Let me So this cell is true and or false value. So I check the middle part. The middle part is starts at 3 and ends at 3. So it's true. Okay, so I need to check now start and end characters. Start character is O and end character is O, so they equal. So here is I should put true. True. So it was here 7 plus 0 plus true, and then FOMA false, and then OMA false. So here is like 7 plus 0 plus 1. Only one substring of length 3 is a palindrome in the MA of OMA string. So next I will check the substrings of length 4. In order to check that one, I need to start from 0 and check strings starting from 0 ends with 3 index. So this MAOF, I need to check middle part. Middle part will start at 1 and with 2, start at 1 and with 2 false. So here is also false. And then I'll proceed, so on to forth, so on to forth. I'll run no palindromes left. So it's gonna be all false. False, false, false. And now I have this triangular matrix. I need to count all the like palindromes, all the cells that have true. So I change it, and now I have what? 8. Result is 8. So generally speaking, I can reduce this matrix. So like the space complexity and the time complexity is O of n squared, where n time, space, O of n squared. So where the n is len len of string. So generally, as you saw, maximum I was referencing like two diagonals, like here. Oh no, oh no, not that. So in order to fill these falses, I was referencing the diagonal that was below this f, basically empty diagonal. In order to fill this for these flags here, let me check. I was referencing like this diagonal. Charles in this diagonal. So like I need to maintain maximum like 2 diagonals. And on the diagonal we have like n, and then on second n minus 1, on third n minus 2, and so on and so forth elements. So at maximum gonna be 2n. So I can reduce space complexity to the S O of n, to the linear time. But it will make the solution less, I would say, intuitive. So I'll code the solution for the 2D like O of n squared space complexity, and yeah, that's it. But generally it can be reduced to O of n space complexity. I guess I was starting like intuitively here with like having this conception of like 1D array, DP one dimensional array, and I was stumbled upon this kind of multiple kind of lengths, and then I figure out that okay, maybe 2D is better here. Yeah. So I'll create the, let's say int n equals s dot length, and then for int I. Okay, so I need also in boolean dp array, two-dimensional array equals new boolean n, and then for. So I need to go by diagonals. This one gonna be 0 diagonal. Like the first one, the main diagonal gonna be this one, gonna be 0D. This one gonna be first D, and so on and so forth. And it will start at like 0 cell, 0 column, then one, the first column, second column, third, fourth, fifth, and sixth. So I'll mark it as for int d equals 0, d less than n, d plus plus. I need to fill the numbers on this diagonal. So I'll do this the following: for int j equals 0, or equals d, j less than n, j plus plus. And in order to figure out I need to go I gonna be j minus d. So, and next I will do this dp of I j should be equal if so there are a couple of options. The option number one, I have like I, so the I is gonna be the start and j is equal end. If I equals j, then it means true. Else I need to check char s char at I equal to s char at j first of all, and there are two options. Either the middle part is empty or middle part is also true, dp of middle part. So if I plus 1 is less or equal j minus 1, then dp of I plus 1 and then j minus 1. Otherwise true. Yeah, something like this. And next I will do this if dp ij, then I'm gonna result plus plus. I'll save the result in the variable result equals 0 and then return result. Okay, so here is j. Yep, that's it. Let's check what I was submitting before. Yeah, this one is basically what I was saying, like this, converting this like 2D to 1D problem, like and saving some time here and there. Like memory, great, time, also good. That's it. Yeah, that's it. I will say that it's plus I had a minor like a mistake. I've been like for a lot of like fail videos here and there. So like we'll add the pass one. Maybe I need some a little bit success. But again, there was a teeny tiny little error in the algorithm. So I will give it a benefit of doubt. Yeah. So that's it.